In this video, we're going to investigate the properties of chords and arcs in circles. To review, a chord is a line segment that has endpoints on the end of the circle. If we investigate, is a diameter a chord? Well, a diameter, if you recall, is a line segment that touches each side of the circle and has to pass through the center. So, yes, a diameter is a type of chord. So every diameter is a chord, but not every chord is a diameter because not every chord has to pass through the center of the circle. One of the properties in our book talks about central angles with congruent arcs. So if we see a circle with a central angle drawn, and I know it's a central angle because my vertex is touching the center of the circle, if I know that this central angle is, for example, 70 degrees, then I know that if this angle, angle P over here, is also 70 degrees, that the two arcs are congruent. So this arc here from A to B would be the same measure as this arc here. Now it seems funny to talk about the measure of an arc in terms of degrees, but recall that a circle has 360 degrees, so imagine yourself walking along the edge of the circle. So if you walked all the way around, it would be 360 degrees. If you walked halfway around, it would be 180 degrees. And so this portion here that I'm highlighting is just the portion of 360 degrees. This next property talks about congruent chords in circles. Well, I noticed that BC sections off, chord BC sections off arc BC here. If I have another line segment that's the same length as BC, if those two are the same length, then I know this arc would have the same measure. So if this was x degrees here from B to C, it would be x degrees here from B to C. Next, I see that a diameter that is perpendicular to a chord, so if I see my diameter and I'm going to mark it as perpendicular, it's going to bisect the chord in its arc. So I know it's cutting it into two equal pieces, so BE and EC would have the same measure arc, so x degrees and x degrees for both of those. Next, I have a theorem that says that if we have two congruent arcs, then I know that they have to be the same distance from the center. So if AB and CD are congruent, I know their distance away from that center point has to be the same. Okay. Our next property talks about a perpendicular bisector of a chord. If we were to go ahead and draw a circle and draw in a chord, if I were to perpendicularly bisect that chord, remember perpendicular bisector has to pass through the center, so the midpoint, at a 90-degree angle. This property says that someplace along this line is going to be my center. In this example, we're asked to find the value of x, and I notice that arc AB has a measure of 120 degrees. I know that the value of x is corresponding to the measure of angle AOB. I notice that point O is the vertex of my angle and it's the center of the circle, which means that this is a central angle. Central angles have the same measure as the arc they intercept. So since AB is 120 degrees, x also has to be 120 degrees. In this next example, we're asked to find the radius of circle A and also the measure of arc CE. We're told that CE is a chord and is 30 inches long, and it is 6 inches from the center of circle A. Well, since I see that I have AT is perpendicular to CE, I know since it's perpendicular, it also must be perpendicularly bisecting. So these two pieces are equal, meaning that each chunk is equal to 15 inches. I can go ahead and close up this figure, and that gives me a right triangle. So I know I can solve for a missing side in a right triangle using a squared plus b squared equals c squared. I'm trying to solve for my hypotenuse, so I can think that 6 squared plus 15 squared equals c squared, or 36 plus 225 is equal to c squared. which leads me to 261 is equal to c squared. To get c by itself, I square root both sides, which gives me an approximate radius of 16.2 inches. I'm also asked to find the measure of arc CE. Well, arc CE, it would be easier to know if I were able to determine the measure of angle CAT. That's a central angle, and if I'm able to figure out the measure of this arc, it would be doubled to find the measure of arc CE. Well, if I take a look at this triangle, it's a right triangle, and I know a couple of my side lengths, and I want to figure out the measure of this angle here, part of my central angle. If that's my theta, I can go ahead and label my opposite, adjacent, and hypotenuse. 15 is opposite, 6 is adjacent, and hypotenuse I found before is 16.2 inches approximately. I'm going to stick with my opposite and adjacent, so I'm thinking tangent or TOA. I know the tangent of theta is equal to the opposite over adjacent, so the tangent of theta is equal to 15 over 6. To get theta by itself, I need to take the tangent inverse of both sides. Tangent and tangent inverse undo each other, and I'm left with theta is equal to approximately 68.2 degrees. So if this chunk here is 68.2 degrees, and I know I'm mirrored on the other side with 68.2 degrees because it's the same triangle, so arc CE, the measure of arc CE, would be equal to 68.2 plus 68.2, or 130.4 degrees. Pardon me, 136.4 degrees. In this next example, we're looking for the value of x, and there's a lot of extra lines in here that make it look a little more confusing than it really is. I'm going to focus in on the diameter that's given, that is 18.8 units long. So my radius is going to be half of that, so my radius is going to be 9.4 units long. Remember, a radius is going to be the same length no matter where it is drawn on the circle, and I notice that this chunk here is a radius, so the entire chunk has to be 9.4 units long. So I notice that x and 4.2 make up that segment that is 4.2 units long. So x is going to be equal to 9.4, the whole thing, minus the chunk we know, so x is 5.2 units long. In this next problem, we're given circle C and we want to find the measure of angle ACE if we know that AB is 5 centimeters and DE is 5 centimeters. Well, AB is 5 centimeters here, DE is 5 centimeters. I notice that both of these chords are congruent, which means that their intercepted arcs also must be congruent. So AB is also 100 degrees. I can take a look, and BE is going to be a diameter. I notice that it's passing through the center of the circle, and I know half of a circle is going to be 180 degrees. So I know that arc BAE, this arc has to be equal to 180 degrees. So if I take the measure of arc AE, that's going to be equal to 180 minus 100, which is 80 degrees. So that's arc AE. ACE, what I'm trying to get at, is a central angle just touching the center, which has the same measure as the intercepted arc, so 80 degrees is the same as the measure of our angle ACE. Central, same.